Welcome back to the second part of chapter number 9 on CCNA cybersecurity operations with me, Joachim Kärrestad from the University of Skövde. In this second part, I will introduce public key infrastructures and digital signatures, quite abstract, so you get the general idea. If you want to have all the technical details, you'll have to go about Googling on public key infrastructure, digital signatures, digital certificates, or something like that, and there's going to be a wealth of information for you to dwell on. So let's start with a slide on digital signatures. So digital signatures are used to sign stuff, and this is to provide authenticity, integrity, and non-repudiation. And the idea here is that we want to know who someone or something is. We want to know the integrity of, for instance, code, and we want to ensure that a sender cannot deny having sent something. And some common use cases are code signing, where a developer can use digital signatures to verify the integrity of an executable. This is widely used to, for instance, automatically ensure that downloaded executables are in fact authentic and should be executed on a system. Another use case is digital certificates that are used to authenticate the identity of a system. So there are some different standards, of course, as always. They include DSA, RSA, ECDSA, and you can go read more about those on your own if you're interested. So let's switch over to public key management. So I'm sure that, as you remember from the previous recording, we have asymmetric encryption. And asymmetric encryption involves each party that wants to communicate encrypted will establish a public-private key pair, so that they have a public key that is usually used for encryption that they share with everyone, and a private key that they keep safe and that is used for decryption. This, of course, introduces the issue that two parties that want to establish an asymmetric connection must exchange this public key information. And how can we do this in a way that ensures that the public keys that we receive are actually from the parties that we want? So to overcome this issue, we have trusted third parties that are there to validate the authenticity of public keys using digital certificates. One such third party is the public key infrastructure, which is a framework for secure exchange of information. They work around certificate authorities that are basically authoritative services that issue digital certificates and authenticate users and organizations. So those certificates are then used to, for instance, sign messages. So if we want to have a small look on how this works. So we have a scenario where we have Bob and Alice that wants to start communicate using asymmetric encryption, and we have a certificate authority in place. So what will happen here is that Bob has received his digital certificate from the certificate authority, and this certificate must be used whenever Bob communicates with other parties. So in this case, Bob communicates with Alice, and when Alice receives Bob's digital certificate, she can communicate with the trusted CA to validate Bob's identity. So now she knows that Bob is in fact Bob, and she can resume communication. So there are actually many vendors out there that provide CA servers and services as a managed service. Those include, for instance, DigiCert, Komodo, VeriSign. If you browse to an HTTPS web page, you can usually click a button, usually the padlock, to view the certificate of that website, and you can see what CA that signed it, and then you can see DigiCert, Komodo, VeriSign, or something else. Some organizations can also implement private public key infrastructures. Usually those are for internal use. CAs, the certificate authorities, they issue certificates based on classes that determine how trusted the certificate is. I'm not going to go through them. They are here for your reference only. So now that we have the ability to establish different public key infrastructures, then we have a problem, because one one CA will of course only be able to validate what it knows about. So is there a way for us to form topologies of trust, so we can have larger infrastructures that are with a cross trust, if you will? Yes, there are. So there are some different topologies that a PKI can form. One is the single root, which is the simplest one. In this case, we have a single root CA that issues certificates to all end users. We can also have a cross-certified topology, and in this case, individual CAs can establish trust relations with each other, and users under any of those CAs can be sure that they can trust users under the other CAs. So this is basically a scenario of one CA saying, "Hi, I trust this other CA, so all of my users can trust all of the users under that other CA as well." Then we have the hierarchical system, where we have one master root CA that can have several CAs under it, that in turn issue certificates to end users. To address interoperability concerns, the IETF published the Internet X.509 Public Key Infrastructure Certificate Policy and Certification Practices Framework, or for short RFC 2527. And what it does is basically that it defines the format of digital certificates, so we can have interoperability between different products. So how do we enroll and authenticate? Well, the first step to enroll a host is to obtain a copy of the CA's public key, and this is called a self-signed certificate. So this is the CA's certificate that is signed by the CA itself. And this is used to verify all certificates signed by the CA. Note here that it's only the CA that can issue self-signed certificates. You got to start somewhere, right? Many different CA certificates are automatically included in systems such as web browsers. So whenever we browse to an HTTPS website, for instance, we can see a green padlock usually that shows us that the website we're browsing to is signed and good. And we can do this because we have a copy of the CA certificate that was used to sign that web page, because it's pre-installed in our web browser. Enrolling with a CA is a process that involves online as well as out-of-band communication. So to do this, a host will have to request and obtain the digital identity certificate for itself, and then get the CA's self-signed certificate. Then it has to obtain the fingerprint of the valid CI identity certificate using some out-of-bands method, for instance a phone call. Having installed certificate from the same CA, two parties can authenticate with each other without the presence of the CA server, because they will each have a certificate that is signed by the CA certificate, and they will have the CA certificate so they can validate the other party's identity. We also have to have some process in place for certificate revocation, because sometimes, for instance, a key gets compromised, or for some other reason, a certificate has to be revoked. There are two common methods that are well used. The first one is called certificate revocation list. In this case, a list of certificates that has been invalidated because they expired. And PKI entities can regularly pull this list for the latest entries. Then we also have the online certificate status protocol, and this is a protocol used to query an OCSP server for the revocation status of X509 certificates, and revocation information is immediately pushed to an online database. So whenever a certificate is revoked, it's pushed to an online database, and then other servers can pull for this information. So let me just end with some applications where PKI is used. It's very well used and very important in online networking. It's used in SSL TLS, certificate-based authentication. Spelling error. It's used in virtual private networks, it's used in HTTPS, it's used in S-MIME for secure email, it's used for secure instant messages, code signing, and a number of different applications. So this was just a rather brief introduction. I hope you managed to follow. I think that I tried to stay true to the material, which in my opinion is a little bit confusing at this point. So, well, we'll leave it there until next time. I'll see you later. Feel free to leave questions in the comments field if you have any.